Okay, hello everyone. It's Salar, and we are in another tutorial part for teaching real-time operating system. And in this part, I wanted to add another option to our real-time operating system. But what is the option? In this part, I want to talk about mutex type. Okay. When I taught the mutex, I said to creating a mutex we can just use SingleShot. But I said if I want to be honest, the type of implemented mutex is not completely SingleShot, and I said in future parts I will implement SingleShot and recursive completely. Okay, in this part I want to implement SingleShot type and recursive type completely. Okay, but what is the differences between SingleShot and recursive type? Let's see the differences here. For a SingleShot type, even owner of the mutex can acquire the mutex just one time. Even owner can acquire the mutex just one time. You can get a SingleShot mutex just one time. If you get a locked SingleShot mutex, a mutex that has been gotten by a thread. If you get a locked SingleShot mutex, the return value will be error, even for the owner. But for recursive mutex, owner will be able to get a locked mutex. Okay, owner will be able to get a locked mutex. You can get a recursive mutex more than one time. Okay, but owner will be able to get a locked mutex. Okay, if a thread gets a mutex two times, to release that, the owner must release the mutex two times. If you get three times, to release the mutex, you must invoke mutex release three times, as many as you get the mutex. Okay, let's see an example before talking about structure of implementation. Okay, in this example, I have one thread 1 with priority normal, and I have one mutex, but the type of mutex is mutex type recursive. Mutex type recursive. We have open declaration, two types of mutexes, types defined here. Two types of mutexes, SingleShot or recursive. Okay, SingleShot or recursive. But when the type of mutex is recursive, let's remove all of breakpoints, reset, and put a breakpoint here. You can get the mutex like before, but if type is recursive, you can get the mutex more than one time by owner. Here is mutex control block. At this time, the value of lock is mutex locked. this value is 1. Okay, the value of lock is 1, but if I get the mutex another time, the status is okay, and the value of mutex lock is 2. This means this is a recursive mutex and acquired by a thread 2 times. Okay, if I release the mutex, you can see the mutex is locked. It's not unlocked. If you want to completely release a mutex, you must release that 2 times because you get the mutex 2 times. If you get a mutex 3 times, to release that, you must release the mutex 3 times. As many as you get a mutex. If another time I release the mutex, now mutex is unlocked. Okay, mutex is unlocked. But let's see an example for SingleShot mutex. Okay, another time I have this example, but at this time the type of mutex is SingleShot. Okay, SingleShot. Run the code until here. I can get the mutex, but if I want to get a mutex another time, a locked mutex, okay, you can see the mutex has been locked. Okay, thread 1 is the owner of the mutex, but for SingleShot mutex you can acquire the mutex just 1 time. You can get the mutex just 1 time. If another time I get the mutex, the status is error. Okay, the status is error. And another time the value of mutex is locked, is 1. Okay, locked means 1. Locked is 1. And just by 1 release, I can release the mutex. A status is okay. Status of releasing is okay. And mutex is unlocked. Okay, mutex is unlocked. This is the differences between recursive mutex and SingleShot mutex. But let's just inspect the implementation of a mutex that support SingleShot and recursive mutex. To get a locked mutex, getting an unlocked mutex is like before, but to get a locked mutex, let's just see here. When a mutex is unlocked, implementation is like before. But if mutex is locked, to get a locked mutex, if other thread than owner wants to get a locked mutex, according to the time, the return value will be error, or the operating system put the thread to the wait list. Okay, if other thread than owner wants to get a locked mutex and timeout is greater than 0, the operating system put the thread in the wait list like before. But if owner wants to get a locked mutex, the return will up to the mutex type. If the type of mutex is SingleShot, the return value will be error, because even owner can get the mutex just 1 time, just 1 time. And if you get a locked SingleShot mutex, the return value will be error. But for recursive matrix, owner will be able to get a locked matrix. If matrix is locked, but the type is recursive, owner can acquire the matrix, and the operating system increase the value of lock by 1, lock plus plus. If the matrix has been locked, but color is owner, okay, color of the matrix is owner. If the type is single shot, return error, but otherwise if the color is owner, matrix lock plus plus. If the type is recursive, if the type is not single shot, the type is recursive, lock plus plus and return OK, lock plus plus and return. But if the other thread than owner wants to get a locked matrix, like before, according to the timeout, the operating system return error or put the color thread to the waitlist like before. Okay, this is the implementation of matrix get when you have two types of matrices, single shot or recursive. Okay, but to release a locked matrix, other thread than owner can't release a locked matrix. The return value will be error. But if the owner wants to release a matrix, the operating system first check the type of matrix. If type is single shot, according to the size of waitlist, the return will be unlock or RTOS return most prior thread and hand over the matrix to the most prior thread. To release a matrix, if a matrix has been locked, if the owner wants to release a matrix, if color thread is owner, color thread is owner of the matrix, if the type is single shot, according to the matrix waitlist size, unlock the matrix or return most prior thread. I've completely inspect and describe this part of code in matrix tutorial. Unlock the matrix or return most prior thread. But if the type of matrix is recursive, the operating system first check the lock value. If the lock value is 1, by just one release, you can unlock the matrix. Another time, like here, check the size. If the size of waitlist is 0, unlock the matrix, but if size of waitlist is more than 1, hand over the matrix to the most prior thread. Otherwise, if the value of lock is more than 1, if you more than one time you get the matrix, just do lock minus minus. Here is single shot and here is for recursive. If the type of matrix is recursive, if the lock value is 1, according to the size, unlock matrix or hand over the matrix to the most prior thread. Otherwise, if the matrix lock is greater than 1, just decrease the value of matrix by 1. Okay, here is implementation of matrix release when you have two types, SingleShot and recursive. Okay, so very good. Now in our real-time operating system we have two types of mutex, SingleShot and recursive. As the name implies, you can get this type of mutex just one time, but for a recursive mutex, owner can get a mutex more than one time. Okay, so very good and very nice. Thank you very much to see me, and see you soon in the next tutorial part. This part was about describing mutex type. Thank you very much.